And welcome back, class. This is Mr. Callan bringing you video for today, Wednesday, April 22nd. Another day of our goal, which is I will find the distance between 2 points on the coordinate plane. Couple things for today. Watch this video, fast forward, rewind, pause, go to some practice or whatever, but that's the second thing, extra practice problems. A reminder that all materials are found in Google Classroom, so please head there. And yes, I do have a challenge activity along these lines for those in need of it. A notes page here from Khan Academy, and then an exercise covering the same material. Wanted to start by pointing out the homework assignment, which you can find on Google Classroom. Distance on the coordinate plane 2 starts with number 7 because I believe the first one was 1 through 6. So 7, 8, 9 here. I wrote skip to backside unless you really need the challenge, or some folks always looking for a little extra practice before Friday's mini quiz. Backside, I think, will be tougher, and that'll be an important part to get ready for Friday's mini quiz. A reminder, please, when it comes to assignments in Kami, I, of course, have some students who are going for the old school option. They write their work down on a scrap piece of paper. Several students doing this, write their work out, take a snapshot, and upload it to Google Classroom. Works just fine. Those of you looking to edit something in Kami, there is an equation box over here on the left, and you can just select your size, select your color. There's even a way to insert symbols like the pi symbol, like the approximately equal symbol. In this case, we would use the Pythagorean theorem. So I'm going to press Shift 6 for the little superscript. A squared plus b squared, Shift 6 again, is equal to c squared, and so on. Now, quite frankly, I am just a drawing kind of guy. This is my finger now. I don't even have my stylus handy. A squared, b squared is equal to c squared. Don't worry about it being neat, folks. Don't worry about it being perfect. Just make it legible. If I can read it, you're good to go. I know that can be frustrating for some of us. So we go back to the overview page, second page, if you want to read through these at your own speed, and that is, how are the problems from Monday, the last assignment, similar? How are they different? And what's a step-by-step set of instructions? Several students saying they have coordinates, and you need to find the distance between those two coordinates, those two dots. Now they're similar because all make triangles that are missing a hypotenuse. If you have a right triangle with a missing piece, yes, you may use the Pythagorean theorem. All the problems, a to the second power plus b to the second power equals c to the second power. They all have roots. If you're going to find one of those missing pieces, the inverse of a second power is a second root. And all the numbers, this is interesting. A couple of you said this. I didn't even realize it. All the numbers are less than 6. All have decimal answers. Maybe next time I'll try to challenge you on with some bigger numbers. But for the coordinate plane, usually the numbers are going to be a little smaller. How are these problems different? Some of them just align, but some of them form a right triangle. Now, this is interesting. If it just forms a straight line where you can literally count the units, it's not required to use the Pythagorean theorem. But if the distance between 2 points is a diagonal and you have to draw a right triangle, then yes, you'll have to use that Pythagorean theorem. Measure differently, different numbers, different answers, and different plots. I love this person talking about the negative, the positive quadrants. Remember, 1, 2, 3, and 4 are the names of the 4 quadrants. Step-by-step instructions. Really love this student doing one step at a time. List out the Pythagorean theorem, find A, find B, multiply those numbers by itself, a squared, b squared, then add those two answers, a squared plus b squared. Then take the square root, because we don't want to know what c times c equals, we just want to know what c equals. So we'll take the square root, round the answer to the nearest hundredth. But you know what I found most interesting about this person is they obviously thought maybe we could call it a step 0 is too obvious. This person, I cut off part of their answer, but they said it. Look, when you begin a problem and you're connecting the dots, almost always you're going to have to make a triangle, a right triangular shape. Very interesting with this person. Making a connection with slope, the rise and the run of the right triangle would naturally make the two legs A and B in that right triangle. I like that connection. Didn't even think about that. And then this person, a little more concise way of saying, create the lines between the two, identify the length and the width, or the A and the B, or the two legs. Insert the numbers in the Pythagorean theorem and solve. This person was a little more explicit with solving. This person is a little more concise. That's what we have for your answers from the exit problems from Monday. And so let's get back to some guided practice problems. Brief review from the other day's practice. If you have 2 points connected on the coordinate plane, now one thing you could do is draw that right triangle. Using the right triangle Pythagorean theorem, we can identify one length and one width, or one leg and the other leg. Now 3 squared and 5 squared makes 34. And of course, we don't want to know what c squared is, so let's get rid of a second power by taking the second root, being fair to both sides. Now you may write this answer 2 different ways. You can write it in the exact way. It is exactly the square root of 34, or you can write it the approximate way. To the nearest tenth would be 5 8/10. Doesn't say feet, doesn't say inches, does say units. Now, if that was too fast for you, pause, rewind, take a look, how to build the triangle, how to find the lengths, how to solve for the missing piece. Or better yet, go back a couple days to the video from the previous assignment and rewatch that assignment. Meanwhile, let's take a look at problems just like today's assignment. I believe this is number 8. Wait a second, how are these problems similar? How are they different? Well, they both have coordinates, but one is graphed and the other isn't. So what's our first step going to be? Pause for a second, think about it. And now that we're back, you might have said the first step should be graphing it, Mr. Callan. -4, -3 down would be here in the third quadrant. Meanwhile, +2 to the right as the x-coordinate, +1 up here in the first quadrant. And we need to find this missing piece. Now, because this is a diagonal, you cannot just count units, but you can create a right triangle, therefore using the Pythagorean theorem. That's going to be very similar to what we did up here, where we can find the length of the 2 legs. If I count very carefully, 1, 2, 3, 4, 5, 6, and 1, and 2, and 3, and 4. 4 squared and 6 squared will make 52. Take the square root of both sides and find an approximate answer of about 7 2/10 units. Now, for those of you looking for the challenge, you can come to number 10. If you want, you're welcome to skip to the backside problem. Attempt to use the distance formula. Now, we've seen this, but it's been quite a while. Whoa, Mr. Callan, what's going on? Well, think about it. Up here, we took the square root, so we're going to take the square root. We're going to square the 2 legs, but how do you find those 2 legs without graphing it? Well, one of the legs is going to be the change from 5 to 9. In other words, subtract those 2. The other leg will be the change from -3 to 1, and subtract those 2. Now, don't even worry about it if they become negative, because once you square a negative, it turns back to a positive. Think about the difference from 5 to 9, or 9 take away 5, is 4. The distance from 1 to -3, 1 minus a negative, the opposite of a negative would be a positive, that also is 4. Very interesting. I didn't imagine these would both be 4. 4 squared is 16, 4 squared is 16, add those together, 32, and the square root of that would be 5 7/10 units. Yes, I suppose we could graph it out, but 9, 1 would go off the graph. So one thing that you would have to do is change the scale of your coordinate plane. Then you can graph 9, 1, and you could graph 5, -3, and you could draw that. But you would see a length of 4 and 4, which is what we found. This is the distance formula. Just want to show it to you before you're expected to master it in high school. Maybe I put this on the homework, on the quiz, as a extra credit kind of problem. But let's head to the back. This is going to be the most important piece. Use the Pythagorean theorem to find the distance between the locations. This is like a real-life map of a town. Note that each unit on the coordinate plane is equivalent to 150 feet. Round your answer to the nearest foot. So not 52.3542 feet. We'll just say 52 feet, 143 feet, 1,627 feet. Let's do 13 together. The distance from the school to the fire station. So we identify the fire station and the school on the graph. And if we're going to find this distance, it is a diagonal. So let's go ahead and make the right triangle. I'm going to draw a vertical line and a horizontal line, hopefully, to find the Pythagorean theorem of the right triangle. Now, you have to be very careful. Where'd this 3 come from? If you look at the scale, The scale does not go by fours. What's halfway between 0 and 4? That would be 2, 2, 4, 6, 8, -2, -4, -6, -8. So if every box counts as 2, 1, 2, 3. Now to go down and find the blue length, 1, 2, 3, 4. And now this is going to look very similar to what we've already done. 3 squared, 4 squared, put those together, take the square root, and 5 units? How can the distance from a school to a fire station be 5 Oh, we'll go back to those directions. It said each unit is the same as 150 feet in real life. Now, I'll give you 2 different choices to convert this to real life. Choice number 1, take 5 units and multiply it by 150 feet. That makes 750 feet. On the other hand, that changed the number at the very end to the real life feet. What if we took the 3 units and the 4 units and changed it at the beginning? We could take 3 times 150, that's 450 feet. 4 times 150, that's 600 feet. And now you look at that and you see, wow, those numbers are quite big. But if you square them and then take the square root, guess what the square root of 562,500 is? It is exactly 750 feet. So, ladies and gents, that will be your choice. You may either use the smaller units and change it to feet at the end, or you may change the units, change the legs immediately to the real life lengths or distances. And while the numbers get quite large, some people prefer this method because there's less error for rounding. Now this one's exactly 750, but usually it's going to be 752.7354 and you have to round it. In this case, it was really nice. If you do this method, don't round that. If it didn't say 5, if it said 4.792, keep that number on your calculator, 4.79, blah, 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 and then just press times 150. So again, you may multiply and change it to real life length at the end, or you may change it to its real life length at the beginning. You will get the same answer. That's all for now, folks. Let me know. Please email, message me if you'd like a one-on-one tutoring session, and take your time and do well.